States launched the Apollo lunar program in the 1960s, it was obvious that telemetry and communications relays would be key aspects of the mission, possibly deciding either success or failure. Although ground stations could provide important links in the relay system, flexible and mobile tracking and relay platforms were needed to cover broad ocean areas. For this reason, the Apollo Range Instrumentation Aircraft, or ARIA, were created in 1968 to provide the vital link between man and space. After the successful completion of the Apollo program, these aircraft were transferred to the Aeronautical Systems Division's 4950th Test Wing at Wright-Patterson Air Force Base. Their basic mission is to receive, record, and retransmit telemetry signals from spacecraft and missiles. To reflect a wider mission, they were renamed Advanced Range Instrumentation Aircraft, still retaining the nickname ARIA. Since coming to the test wing in 1975, the ARIA have supported a wide variety of programs for NASA and the Defense Department. They have proved to be a unique and invaluable instrumentation resource. 7 aircraft comprise the ARIA fleet, designated as either EC-135s or EC-18Bs. The most obvious feature of an ARIA is its large, bulbous 10-foot nose. It houses a 7-foot steerable dish antenna, which is used for telemetry reception in several different frequency ranges, primarily S-band, or 2200 to 2300 megahertz. In addition to the nose antenna, each ARIA has probe antennas on both wingtips. And some also have a trailing wire antenna on the bottom of the fuselage. These are for high-frequency radio reception and transmission. Other antennas on the exterior include those for data transmission. The cargo compartment of the aircraft houses all of the instrumentation modifications. Altogether, they comprise a 30,000-pound modular package of electronics, known as prime mission electronic equipment. Basically, this equipment is separated into 5 major subsystems manned by electronic technicians, a radio operator, a systems analyst, and a mission coordinator. At the antenna control console, the operator manually controls the large dish antenna with a joystick or a thumb wheel. He receives the initial acquisition signals from the ARIA's tracking receivers and then manually steers the dish. Once he acquires the vehicle, the antenna can then track automatically using the receiver signal. The tracking and data receivers are at another console, automatically feeding the antenna subsystem with elevation and azimuth information on the spacecraft or missile. The scopes display signal strength and frequency. The technician continually tunes his receivers to account for frequency changes during data reception. From the receivers, signals are also fed to the data separation console, where they can be formatted for recording or transmitted to the test range by satellite. Even when processing is not required for the mission, the technician must monitor all incoming data to ensure its quality. At the recording and timing station, the processed signals are recorded for later analysis. 2 14-track recorders are available for this purpose. They can run at several speeds up to 120 inches per second. An electronic technician monitors the signal level of each track individually. Meanwhile, time code generators allow the precise time to be recorded simultaneously with the data. A portable clock is synchronized with the satellite timing station before takeoff from Wright-Patterson and then maintained to within 2 microseconds throughout the mission. This tolerance is well within normal customer requirements. During the mission, the communications technician provides both voice and data communication support. To do so, he uses 3 1,000-watt single sideband high-frequency receivers and transmitters and a 1,000-watt satellite terminal for data transmission. He controls all of the antennas except the large dish. An important member of the instrumentation crew, although he has no specific station, is the systems analyst. He is the senior NCO who monitors systems performance during the mission, checking on operations and procedures. Finally, all of the efforts of the electronic technician are combined under the direction of an engineer, the mission coordinator. This crew member monitors all of the instrumentation stations and provides coordination between the aircraft and Araya control at Wright-Patterson. He also controls the power and environmental systems for each of the electronic subsystems. Up front, the air crew for Araya missions is the normal complement for this series of aircraft. It includes 2 pilots, a navigator, and a flight engineer. A typical Araya mission begins many months in advance of the actual flight. It is usually scheduled by one of the test ranges, either the Eastern Space and Missile Center at Patrick Air Force Base, Florida, or the Western Space and Missile Center at Vandenberg Air Force Base, California. The schedule for a particular mission is determined by the range. At the Araya Engineering Division of the 4950th Test Wing, the aircraft is tentatively scheduled. The person most closely involved with the project at this stage is the mission planner, who becomes the focal point for the project and gathers support requirement information over the next several months. Real activity for the mission does not increase until about 60 days beforehand. In the following weeks, the requirements for the mission are fully determined and published in a Wing Operations Directive, specifying the numerous details to be arranged. For example, if a real-time relay of data is required from the aircraft, the mission planner must schedule the appropriate satellite so the data will be retransmitted to the test range as it's received during the mission. The Data Facilities Group, which operates the telemetry simulator, must also be scheduled so that all of the electronic equipment on board the Araya can be precisely calibrated before takeoff. All of the electronic technicians must be briefed on how the equipment will be set up for the mission and the type of data to be acquired. Passports must be checked and visas acquired if necessary for all crew members. And finally, an overall task force briefing is held prior to the deployment to bring together everyone involved in the mission. In addition to the technical personnel, this includes the flight crew and any maintenance personnel who will be a part of the team. With a minimum of 3 days prior to takeoff from Wright-Patterson, the instrumentation operators go on board the Araya to calibrate the equipment each will use during the mission. If any special equipment is added for a particular mission, this task can take up to 6 days. With the aircraft parked in a pre-calibrated parking space on the test wing ramp, the Data Facilities Group generates signals and transmits them to the aircraft, simulating those it will receive during the mission. On board the aircraft, each of the technicians must adjust his equipment so it will perform exactly as necessary. This task also allows the technician to familiarize himself with any peculiarities of the unit. For the mission, a minimum crew on an Araya is 12 people, including 8 instrumentation personnel and 4 aircrew members. However, each Araya can accommodate 24 people, and a full complement is generally carried on each mission. 3 additional aircrew members for long flight, maintenance personnel, and several instrumentation trainees usually make up the difference. It normally takes about a year to train an Araya electronic technician. Depending on where the Araya will be staging, which could be at any of about 30 locations throughout the world, it leaves Wright-Patterson in enough time to arrive at its remote base 24 hours in advance of the mission. The early arrival is necessary to correct any maintenance problems that might be discovered en route. Although only one Araya is normally mandatory for a mission, a second aircraft is usually scheduled to extend data coverage and ensure mission success. While in flight to its staging base, the equipment operators again check their systems. If the mission will involve a real-time data relay, the operators will use a simulation tape provided by the test range to perform a data flow check. It entails transmitting the data to the range via satellite. This enables both Araya and range personnel to familiarize themselves with the procedures for the mission. Then again, on the day of the mission, as the aircraft flies to its test support position, the Araya does another data flow check with the test range to practice for the mission. The aircraft arrives at its support position at a precise time prior to the launch of the spacecraft or missile. Typically, it will remain on station anywhere from 30 minutes to 2.5 hours for the mission. While the mission is in progress, an Araya control support team is activated in the wing's Aircraft Operations Control Center at Wright-Patterson. The team is in constant contact with the mission coordinator on board to direct aircraft activities and provide the interface between the Araya and the test range. Regardless of where mission activities occur throughout the world, the 4950th Test Wing is responsible for the maintenance and logistics support of the Araya fleet. For aircraft maintenance, up to 5 maintenance specialists will be scheduled for a mission if the Araya will be deploying to a remote location where maintenance will not be available. For the extensive electronic equipment, each technician is not only capable of operating it, but also certified to repair it. At home, the test wing operates a maintenance facility devoted solely to maintaining Araya prime mission electronic equipment. Although the Araya fleet already possesses advanced instrumentation systems, it is the nature of research and development to be continually growing. For this reason, the Araya Engineering Division stays abreast of future support requirements and continually updates its electronic subsystems to meet these demands. The largest improvement to the overall program, however, has been the acquisition of the C-18 aircraft. These are commercial Boeing 707 series aircraft, which the wing acquired and, through an ambitious in-house modification program, converted to EC-18B Araya airframes. The EC-18s are larger and capable of carrying additional mission equipment to meet future range requirements. Despite their commitments to orbital and re-entry missions, the Araya also have a long-term support role in the air-launched cruise missile program. This support is not at all typical because the Araya must continuously track the missile for more than 5 hours. In addition, the missile almost always flies below the Araya, which relays real-time data directly to ground stations. At the same time, voice transmissions are relayed between the chase aircraft and mission control through remote ground stations. For some missions, the Araya assumes the command and control role. Similar activities are performed in support of the Advanced Medium-Range Air-to-Air Missile Program. No matter what the mission, Araya and the dedicated people who man these unique aircraft have always risen to the task. Araya have supported customers from around the world. Most missions involve NASA and DoD payloads. However, they have also flown in support of orbital and ballistic launches of several NATO allies and other friendly nations. This support is as unique as the aircraft themselves. Araya are truly national assets. That's why they are painted with the words United States of America, normally reserved for presidential and State Department aircraft. Advanced Range Instrumentation Aircraft, the nation's vital link to its spacecraft and missile systems.